this is worksheet 5 of the atomic structure packet, and the good news is that this is the last of the 3 diagrams that you're going to need to learn how to draw in this packet to represent atoms. Remember, I started off saying we have all these different ways of representing atoms simply because they're too small for us to see, and so it's hard for us to talk about them if we don't know what they look like, right? So we need to have common ways of drawing what they look like. So this last diagram, for most students, is honestly the easiest one. You just have to keep all these diagrams straight now, all right? Lewis dot diagrams are the diagrams that we are going to use later on when we get to our bonding unit. We're going to use them in Chem B, and they're really helpful because all they show us is information about the valence electrons in an atom. So they cut out a lot of the extra information and they just tell us about the valence electrons. And when we're talking about chemical reactions, the interactions of atoms with each other, it's the valence electrons that really matter. The protons and the neutrons and all the inner electrons kind of stay put, and just the electrons in the outermost shell are what move around. All right, so if we go back to the good old electron configuration of chlorine. Okay, we've used this example before. Here's the full electron configuration here, right? Hopefully you could write one of these based on reading off the periodic table. And it tells us where all of chlorine's 17 electrons are. Okay, it tells us, so I have circled in red, that in the first shell, right, there's an s orbital that contains 2 electrons. So here's your first shell, drawing this in, here are your 2 electrons. Okay, and it tells us that in the second shell there's an s and a p orbital. So the second shell is kind of divided into 2 spaces, and the s orbital holds 2 electrons and the p orbital holds 6, and so here they are drawn as a total of 8 electrons. All right, and in the outermost shell, here's the valence electrons, right? This is what we really care about here in green. We've got 2 electrons in an s orbital, and then we've got just 5 electrons rather than 6 in the p orbital. Chlorine's missing 1 electron from that 3p orbital. So here's the outermost shell, and it's got just 7 electrons, which we know from the last worksheet makes chlorine a little sad. It'd like to have 1 more, and we'll get to that. Okay, but for now, to just draw chlorine as the neutral atom that it is, right, all we're going to do is we're just going to draw Cl, the symbol for chlorine, right in the middle here, and then we're just going to represent only those 1, 2, 3, 4, 5, 6, 7 electrons in the outermost shell. Forget all the other ones. So we draw 7 dots around chlorine. Okay, now, some teachers get really picky about where you draw the 7 dots and the order that you put them on. For me, life's too short. Okay, just for your reference, some teachers refer their students to this diagram, and they say, well, the first dot that you draw goes here, the second goes here, the third goes here, the fourth goes here, the fifth goes here, the sixth goes here, the seventh goes here. And so in the case of chlorine that doesn't have an 8th electron, your empty space should be here. Okay? For me, I'm not going to freak out about that, but all I ask is you put no more than 2 electrons on each side. And we'll learn more about why that is when we get into our bonding unit, but we normally partner electrons up 2 by 2. And if you get into the habit of that now, it's going to make it easier once you get to the bonding unit. Okay, so let's do a couple of problems here, and then you'll finish these when you get to class. We ask you to write the abbreviated electron configuration, so you get more practice with that, and then also the electron dot or the Lewis dot diagram. Lewis was a guy who came up with this diagram, go figure, right? Okay. Now, hydrogen you can't really write an abbreviated electron configuration for. Sorry, it's just is what it is because it's so small. So hydrogen, here's its symbol, atomic number 1, mass of 1, and it's just got a 1s orbital with 1 electron in it. I don't know how you abbreviate that. Okay, so its first orbital, or its first shell, is its outermost shell. So this electron right there, that is its valence electron. So here's hydrogen, we'll make a little dot. Okay, now I really don't care. Some of you guys might put the dot here. That's fine with me too. It doesn't matter which side you put it on, as far as I'm concerned. All right, that one was kind of a cheap one, so let's do one more. Okay, beryllium has a mass of 9, an atomic number of 4. Right, you gotta read that off the periodic table. The noble gas that comes just before beryllium is helium. Not much of an abbreviation, but hey, we'll take it. And so then following after helium, going on to lithium is in the 2s orbital. Both lithium and beryllium are, so we've got 2 valence electrons in this outermost shell, in this second shell. So we write Be. We put a dot here. Oh, and here's what I'm going to be picky about. We put a dot here. If you can space the electrons out and not make them partner up on sides, please do that. Again, just because when you get to the bonding unit, it'll be a help for you to have gotten in that habit. Okay, now, so far all we've represented with these Lewis dot diagrams are atoms. Neutral atoms that aren't interacting with other elements, and they're a little bit sad because they don't have full outer shells. Okay, so let's think about ions and how we could use the same kind of a diagram to represent an ion. Okay, so I want you to remember the definition. Ions are formed when an atom either gains electrons to become an anion or loses electrons to become a cation. And the reason they're gaining or losing electrons is because what they're really trying to get is 8 electrons in their outermost shell. Or if you're teeny tiny little hydrogen, right, your outermost shell can only, as a 1s orbital, can only hold 2 electrons. So in that case of hydrogen, you just want to have 2 electrons in your outermost shell. So let's go back to our chlorine example. Okay, this is the Lewis dot diagram that we just drew for the atom of chlorine. Remember, it had 7 valence electrons, and that means that it's just one short of having 8, of having a full shell. So it's going to try to steal an electron from another atom. So here we're assuming that there's some other atom in solution with it, maybe sodium, right? Maybe it's salt water. All right, and so it's going to steal an electron. Don't worry right now about specifically maybe where it came from. Okay, and so we're going to show this by redrawing chlorine, right? But this time we're going to put 8 dots around it. We're going to draw that extra dot, showing that it's stolen an electron from somewhere else, maybe from sodium, and it tacked it onto its own valence shell. Now, we do have to put some little brackets around it and then specify that that means it now has a -1 charge, right? Meaning that 1 negatively charged electron was added. Okay? All right, now remember, that was the case of chlorine that had 7 electrons, is that it stole an electron, took a negative charge. You can also, so that was an anion, you can also draw a cation. Okay, so that would be if you have an atom that has less than 4 dots when you draw its Lewis dot diagram, right, less than 4 valence electrons, well then you're going to show that it's giving the electrons away, and so you're going to put 0 dots around it, and you're going to still put a bracket, but then you're going to have to put a positive charge, like a +1 or a +2. Okay, so let's look at a couple examples. All right, we'll do hydrogen, we'll do fluorine, and then you guys can do beryllium and phosphorus on your own. So hydrogen, right, before when we drew hydrogen, if you look up here, it had its little 1 valence electron. Okay, now it would like to get rid of that, so it doesn't have just 1 electron in its outermost shell, because remember, if an atom has less than 4 dots, well, it has 1 that's less than 4, it's going to give those electrons away until it has no electrons in its outermost shell. So hydrogen, we're going to draw with no dots around it. We're going to put brackets. We're going to say since it got rid of that negative, it's now positive. Okay? Fluorine, okay, it turns out that it has, it's in group 7A, right? So it's got 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. All right. And what it's going to do then is it's going to steal an electron from somewhere else. So we'll add that in. And that means it's got an extra negative charge, an extra electron. So it's going to have a -1 charge. Okay? So we will practice this a little bit more when you get to class, and then you will know how to draw all of the diagrams for this unit.